Hi, I'm Angeline Katausan.
My name is Courtney Kendrick.
I'm Braden Lee,
I'm Kylie Lee. And I'm Erin Zog.
and this is our interdisciplinary Group 4 project. We have HL biology students and SL chemistry students. The theme this year was heat. So we did a little bit of background research about wood frogs and how they're able to freeze themselves in the winter. And then thaw out with little cell damage. And this contrasts with other biological systems that would usually experience some severe cell damage.
Alaskan wood frogs spend nearly 7 months of the year frozen solid, and in the spring they thaw and are able to resume daily activities. They do this by a gradual process of freezing and thawing, so they freeze at night and then thaw during the day. So typically when tissue is frozen, water is drawn out of the cells, causing dehydration and eventually death. However, wood frogs, as they gradually freeze and thaw, they're able to convert glucagon in the liver into glucose and store it inside the cells. So this higher concentration of glucose inside the cells prevents water from being drawn out and death. So we wanted to apply this information in our Group 4, and we wanted to experiment with frogs or other mammals. However, due to ethical implications and potential agricultural benefits of cryoprotectants, we decided to focus our research on plants.
So with this biological phenomenon in mind, in terms of chemistry, we needed some solutions to work with. With what was available to us, we came to using ethylene glycol and glycerin. Now, in terms of molecule structure, they're very similar because they can form hydrogen bonds with water as they go in a water solution. And this prevents ice crystals from forming in a cellular system by forming those hydrogen bonds and preventing ice crystals from forming. So it will reduce damage to the cell structure. Ethylene glycol, however, is the more dangerous of the two. It tends to be toxic to biological systems. But with this in mind, we came to our research question. That was, is it possible to reduce the damage to cells in plants after freezing using cryoprotectants such as ethylene glycol and glycerin? This helped us come to our hypotheses that, given that ethylene glycol is a toxic substance, we predicted that it's still going to kill the plant, though both of them will help reduce cell damage as we freeze and then thaw out our plants.
So onto our planning and procedure. We began with creating our concentrations of ethylene glycol as well as glycerin. So by taking these chemical properties and looking at their volume, we were able to dissolve them, or dilute them I should say, into concentrations of 85% and 50%. From there, we moved into creating 5 groups of our radish plants. So we began with a control group in which we watered with just water. This is our neutral treatment. Then we had an ethylene glycol 85% solution. We had an ethylene glycol 50% solution. We had a glycerin 85% solution and a glycerin 50% solution. All of these would be examined and to see if the concentrations would affect it and to see how the chemicals would affect it. We then moved into deciding that we wanted to slowly introduce these chemicals to prevent from shock. So we began watering with 5 milliliters, 10 milliliters, 15 milliliters, and then 20 milliliters.
And so we began planting the radishes a few weeks before we started making our solutions, so that it gives the plants time to germinate, and then it'll be mature enough for us to move into their separate containers. So after a few weeks, we move them to their separate containers so that we can water them, and none of the chemicals will get mixed together. And we also want to note that due to some construction and the environment in the greenhouse, we weren't able to water our plants very well, so they were close to dying when we were able to get access to them again.
So now onto our freezing process. After having watered them for a number of 2 to 3 weeks with our different concentrations at different moments of time, we decided we need to put them into cooler climates so we can test the freezing aspect of it. In doing so, we realized that we needed to introduce it slowly. As Erin had mentioned earlier, frogs go through this slow process of freezing and thawing until they eventually get to a point of freezing entirely. So we wanted to make sure we didn't put them too quickly into a freezing environment, or else it would create shock and all the cells would burst anyway. So you slowly moved them from the hottest temperature, which was the greenhouse climate, to a classroom temperature, or I should say room temperature, and then to a fridge temperature, and then into a freezer temperature. Following that, we did the exact opposite. We moved it from a fridge to a classroom and left it in the classroom until we were able to examine the cells.
So after watering them with our last solution, we took the plants we let the plants thaw, and after thawing, we were able to get access to the plant roots, and we decided to analyze the root tips of each of the radishes due to some unforeseen circumstances. We weren't able to water them, so we wanted to see if they were still alive when we put them on when we froze them. So the best place to see plant growth was on the root tips, because that's where we'll observe mitosis. And as we pulled out each of the plant roots, we stained them with glucose in order to better see the cell structures.
This is a picture that we took of one of our control group plants. So as you can see, the cells are typical plant cells. They're very structured, very organized. However, our control plants were the driest of all of our plants, and this was due to the fact that we watered the control group and the plants with chemicals with the same amount of liquid, and as plants filtered through the chemicals, they uptook the water slower, but the water was taken up quickly, causing dehydration. The cell structure of the ethylene glycol plants is in disarray. We can infer that the ethylene glycol interrupted processes of mitosis and caused irregular cell growth. It's a stark contrast between the ethylene glycol cells and those of the control group. We can see that these are much more chaotic. However, in the glycerin cells, you can see that watering them with this chemical has created a thicker cell wall. Darker spots within the cells, we can infer that the cells watered with glycerin were still alive when we put them in the freezer.
The toxicity of the ethylene glycol solution in both concentration amounts had a very negative impact and really interrupted mitosis and the cell growth and structure. Whereas the glycerin was less toxic, and it definitely helped as a cryoprotectant more because the cell walls are darker and the striations of mitosis are still visible. So we can see from this that the glycerin is definitely a better chemical to use in plant cell growth.
So now we'll talk about our entire project, as we've already heard from all the planning stages.
So a real-world application of this experiment is that it's very useful when it comes to agriculture. If this was successful, then we could easily freeze plants and have them still alive, which is useful for in times where there's a drought. There's you're less likely to grow plants. So if we are able to freeze plants and still keep them alive, then we can easily get food from other resources other than relying on the plants that are grown during a certain season.
Also, the chemicals used, we can see that ethylene glycol, although it is a very good cryoprotectant, it's not as applicable in living organisms. So although we can definitely still use it in machinery such as cars, if we're using something with living organisms and biological substances, then we should use the glycerin to help prevent cell bursting in the process of cryogenesis.
One final thing to conclude on before we end our presentation is some things we could do for next time experimentation. Firstly, we would probably get a different greenhouse or a greenhouse that we can manage better so that our plants won't die and we have better results. The second thing we would probably do is be able to see if we could figure out the concentrations within the cells after having watered them. We know what concentrations we watered them with, but the concentration of that present in the cell, or in the group I should say, would be really helpful to examine, as we can see if it's actually going to reduce or not. So that is our presentation.
Thank you very much.